Welcome back everyone, I am Saptaparni from BioLive. Hope all of you are doing very well. So in today's video, we are going to discuss about a term related to chemistry of carbohydrates known as mutarotation. So from the name, it is evident that it is talking about the mutation or slow changes in the optical rotation. Okay, now first of all, what is optical rotation? Optical rotation means when a plain polarized light is passed through a solution of carbohydrates containing anomeric carbons, okay, then the direction of plain polarized light gets changed. If it rotates towards the clockwise direction, we call it as text rotation, and it is designated as small d and with positive sign. Okay, and if the opposite occurs, that means the rotation is changed towards anti-clockwise direction, then we call it as levorotation, and the it is designated as negative sign. Okay, got it? So this is the optical rotation. Now in case of carbohydrates, we know that there are cyclical forms like this one and this one. Okay, and in cyclical form of carbohydrates, anomers are found. Okay, alpha anomer and beta anomers are found. Now these names of alpha and beta anomer are dependent on the position of hydroxyl group with respect to the anomeric carbon. Okay, in case of glucose, the anomeric carbon is C1 or the first carbon, and if the OH group is situated below the plane of this anomeric carbon, we call it as alpha anomer. Okay, and in case of beta anomer, you can easily see that the OH group is situated above the anomeric carbon. Okay, now what happens if we make a solution of this alpha D glucose or alpha D glucopyranose, whatever, then there will be obviously a optical rotational value or specific rotation value if we pass a plain polarized light through this. Okay, so initially the optical rotation value or the specific rotation value is 100 and plus 112.2 degree. Okay, but it was seen that slowly this value gets changed, okay, and it changes or mutates until it reaches an equilibrium rotational value of 52.7 degree. Okay, see here, this is the equilibrium where the optical rotational value or specific rotation value is plus 52.7 degree. So until it reaches the 52.7 degree, this alpha D glucopyranose slowly changes its structure. Okay, and at 52.7 degree, you will see that there is a free or open chain structure of the D glucose. Okay, similarly, on the other hand, the initial optical rotation of the beta D glucose or beta D glucopyranose is plus 18.7 degree. Okay, and after few hours it slowly changes and attains this value plus 52.7 degree. Okay, and at that time open chain structure is formed. Okay, so you can easily see that these alpha and beta anomers are slowly changing their optical rotation, okay, or mutating their optical rotation until they reach an equilibrium of a specific rotation plus 52.7 degree. Okay, so this slow interconversion, slow but spontaneous interconversion of alpha and beta anomers of reducing sugar via their open chain structure to give an equilibrium stage is known as mutarotation. Mutation means slow change. Here the optical rotation is slowly changing. Okay, that is why the structure is also slowly changing. Actually, the vice versa, the structure is slowly changing. That is why the optical rotation is also slowly changing or getting mutated. Okay, so got it? What is mutarotation? Now, it was seen that at equilibrium stage, 1/3 portion of the solution is made up of alpha chain alpha anomer, and 2/3 portion is made up of beta anomer. Okay. Now, another example is fructose. In case of fructose, the alpha anomer has an initial optical rotation of -21 degree and beta anomer has an initial optical rotation of -133 degree. But at equilibrium, the mixture of these two anomers have an overall specific rotation or optical rotation of -92 degree. Okay, this is an example of levo-rotation, and glucose is for the example of dextro-rotation. Okay, got it? Now, there are also some exemptions. Okay, for example, sucrose and trehalose does not show any kind of mutarotation. Why? Because as we have seen, the presence of anomeric carbon is very important, okay, for mutarotation. Presence of anomeric carbon and its free hydroxyl group is very important. But in case of sucrose, we can see that the sucrose is made up of one moiety of glucose and one moiety of fructose. And for glucose, the first carbon is anomeric carbon, and for fructose, the second carbon is anomeric carbon. But in case of sucrose, the bond is formed between these two anomeric carbons. Okay, the beta 2,1 glycosidic bond is seen. That is why two anomeric carbons are already bonded, so there is no free hydroxyl group, so it cannot show any kind of mutarotation. Similarly, in case of trehalose, two glucose moieties are bounded to each other by alpha 1,1 glycosidic bond, and we know that for glucose the first carbon is anomeric carbon, and here both the first carbon are already bounded to each other, so no free hydroxyl group is present, so no mutarotation can be seen in this case too. Okay. So I hope now what is mutarotation is completely clear in your mind. Okay, and if you have any more doubt, you can leave a message below. I will obviously try to answer that. And if you like this video, don't forget to hit the like button, share it with your friends, and don't forget to subscribe to my channel for more such videos. Thanks for watching and happy learning.